One of the importance of the speed of light is that it serves as the single limiting velocity in the universe, being an upper bound to the propagation speed of signals and to the speeds of all material particles. But in the derivation of the speed of light, there are four equations that play an important role. The four Maxwell's equations. Maxwell's equations represent the concise way between the fundamental relationship of electricity and magnetism, wherein it consists of Gauss law for electricity, Gauss law for magnetism, Faraday's law of induction, and Ampere's law. Gauss law for electricity tackles the charge present inside the Gaussian surface that emanates electric field multiplied to surface area, which led to conclusion that it is equal to charge enclosed over the permittivity of space. Gauss law for magnetism tackles that the magnetic flux entering the Gaussian surface is equal to magnetic flux leaving the surface. This is why the integral of magnetic field times the area is equal to 0. But then again, due to symmetry, Gauss law for electricity and magnetism in relation to electromagnetic waves is 0, so it doesn't contribute too much on the speed of light equation. Faraday's law of induction describes how change in magnetic flux induce electric field, in which in turn, if we relate this equation to electromagnetic waves, we then have electric field is equal to C times the magnetic field, which is the electromagnetic wave in vacuum in relation to Faraday's law. Finally, we have the Ampere's law, which describes how the induced current and the change in electric flux create a magnetic field. But in relation with electromagnetic waves, we assume that there is no induction current, resulting to equation B is equal to mu sub naught times epsilon naught times E times C, which is the equation for electromagnetic wave in vacuum in relation to Ampere's law. Now that we get the two important equations for electromagnetic waves, the one we obtain in Faraday's law and the one we obtain in Ampere's law, we then now derive the value for speed of light. First, let's use the equation we obtain on Ampere's law and simplify it by dividing E both sides. Then we end up on this equation. Then now let's use the equation for Faraday's law for finding the value of B over E, which is also equal to 1 over C. Then by further simplifying the equation, we then now deriving for the equation for the speed of light, which is this one. Now that we have the equation for the speed of light and we have the values of constants, the permeability of space and the permittivity of space, we then now substitute the values, then now we get the speed of light.